Students, data rate limits की बात कर रहे हैं, calculating how much data we can transmit over a channel or a transmission medium. Students, we discussed the Nyquist bitrate formula. Now we are going to be talking about the Shannon model or the Shannon formula. Students, we know that Nyquist bitrate formula is for a channel which has got a noise that is equal to 0. Nyquist bitrate formula can only be applied to a noiseless channel. Now, students, Shannon gave us a formula which we can apply to a noisy channel, which is a more realistic scenario. We know that a noiseless channel is just an ideal thing. It's an imaginary thing. There is no channel which does not have any noise. Now, students, in 1944, Claude Shannon gave us that formula, and we'll go to the slide and we'll have a look at that formula and how to make calculations using that formula. Students, the capacity or the Shannon capacity, the formula to calculate that is bandwidth multiplied by log to the base 2, 1 plus the signal to noise ratio. Students, this bandwidth is actually the bandwidth of the channel. The SNR is the signal to noise ratio. You know that. And our capacity is nothing, capacity or Shannon capacity is nothing but the capacity of the channel. Once again, this capacity is actually telling us what is the theoretical maximum bit rate of this noisy channel. Students, an important point to note is that we do not have any quantitative inclusion of the number of levels in this formula. There's no levels. Nyquist bitrate ke formula mein, you saw that in that particular case, our bitrate was directly proportional to the number of levels for a noiseless channel. As per Shannon's capacity formula, it doesn't matter how many levels we have, we cannot achieve a data rate that is higher than the capacity of the channel. So students, our max theoretical bit rate is always going to be lesser than the capacity of the channel, which is the actual case in reality that we have for the real-time data communication systems. Students, एक example देखेंगे. In this case, we have got an extremely noisy channel in which the value of the SNR is almost 0. Your signal to noise ratio is close to 0. In other words, the noise is so strong that the signal is faint. For this channel, we need to find out the capacity. The formula that we have is bandwidth multiplied by log to the base 2, 1 plus the SNR. This is equal to B, which is the bandwidth once again, log to the base 2 of 1. Log to the base 2 of 1 is 0. Multiply by 0. This comes out to be, forgive my maths, is 0. What this means is that the capacity of the channel in which the noise is extreme, in which the signal to noise ratio is 0, regardless of the bandwidth, the capacity of such a channel is 0. Even if you have infinite bandwidth, when you multiply that with a 0, which is log to the base 2 of 1, signal to noise ratio close to 0, then you get a bit rate of, or a capacity of 0. What does that mean? The capacity of 0 means we cannot receive any data through this channel. Students, moving on, we have got a theoretical highest bit rate of a telephone line. Bandwidth is 3000. Signal to noise ratio of a telephone line is usually 3162, and the capacity is calculated as multiplied by log to the base 2 of 1 plus 3162, and this comes out to be 34860 bits per second. So students, what this means is that the highest bit rate for a telephone line is 34860 bits per second, and if we want to send the data faster than this, then we need to increase the bandwidth of the line. Or what's the other factor? We need to improve the signal to noise ratio to make it better than 3162. If you don't do that, if you stick to the standard values of the bandwidth and the signal to noise ratio of a telephone line, then we end up with the capacity which is equivalent to 34,860 bits per second. Students, आपने देखा कि Nyquist bitrate formula was what we use for a noiseless channel. A channel that does not have noise, does not exist. And then we had a Shannon capacity formula which we used for a noisy channel. Students, मैंने आपको बताया था कि in theory we actually use both of these formulas to calculate the limits of the data rate, the maximum theoretical capacity or the data rate that we can have on a particular channel. Students, Shannon formula, it gives us the upper limit. And the Nyquist formula, because it includes the levels, it gives us the number of levels that we can have in the data representation that we are going to be transmitting over the transmission medium.